Alright, guys, just to continue on with our lecture, we just got to finish up a few things. Sorry, I had our mistake in the last one. I fixed some of the problems I had in our display here and showed how we could do our formula. But so if we figured out that E, of course, has to be equal to our 300, so that was our first one, and then D, if we have 60 going to the left, that means that there's going to be a 20 in our D. If we wanted to do that math-wise, we would say F net is equal to 80 minus D, and then plug in that. We'd have to subtract 80 on both sides to solve for D. That would leave us with 60 minus 80, so we'd have a negative 20 newtons, but we'd also have a negative D, so we'd have to divide by negative 1 on either side to get 20 newtons on the right side for D. Our last example here before we're going to look at our simulation that I finally got to load is this one. We have a few different ones to go. So our F net here says that we're going to need to be going 30 newtons to the right. So 30 newtons to the right, but what does that mean for F and H? Well, if we're only going to the right and we're not going up and down, that means that F and H have to be the same. So they could both be 0 newtons, they could both be 100, it doesn't matter as long as F and H are balanced, are exactly the same. And then what does that mean D needs to be? Well, we're going 30 to the right, so that means that we can say F net is equal to, I have C again, sorry, G minus 20. Then we're going to have to add 20 to the other side of our equation to get 50 newtons to the right. Again, we can just do this in our head sometimes, where we have 20 newtons to the left. If we are going to have a total of 30 to the right, 50 minus 20 gives us 30 to the right. So 50 is G. G is going to be 50 to the right. So our quick summary of the important definitions is that our applied force is the force put on an object. Our gravitational force is the force from gravity. Our normal force is our force perpendicular, which means 90 degrees to the surface of an object. Our friction force is the force opposite of object's movement. For our net force, it's the sum of all the forces, and if they're in opposite directions, we subtract, or in the same, we add. But I wanted to show you guys this simulation because I think it does a good job. We can see here that as I put different people in this tug of war, that we have their different forces. So this very big person can pull with a force of 150 newtons, but this very small person can only pull with a force of 50 newtons. And then up here it says the sum of forces. So it has subtracted our 150 minus 50 to get 100, and it's going to go in this way. If I hit go, we all know that our big person is going to pull more than our little person, and we can see that going to the left because we have an unbalanced force. Let's look again. What if we put a big person on this side? So now, since they're pulling together, we get the force of one person, which we said was 50, plus the force of a big person, which is 150. We add them together to get 200. So now we have two people pulling against one person. Our sum of forces, because 200 is bigger than 150, is going to make us go to the right. So we can see we're pulling all the way to the right until the red team wins. And now let's look at the case when they are the same. So what happens when we put 250 newtons to the left and 250 newtons to the right? Our sum of forces is 0. When I hit go, nothing happens because we have a balanced force. So I think this is a good way to kind of picture and visualize and see exactly what I mean by balanced or unbalanced forces. I'll put this link in our classroom if you guys want to play around and put different people and just to test it for yourself as well. But that is all I have for you guys today on net forces. I hope that our lecture made sense. Sorry that it took 2 videos for me to get through everything, but if you guys have any questions, please let me know.